Welcome to the community call. And next slide, I think we can go over the agenda. Okay, so first, I'll talk about some resources we have for you to learn more about topology protocol and get involved. And then it's the spoiler, because I still don't know it, so it's going to be a very cool thing to see. I'm as excited as you are. And then we're going to talk about the development updates from the topology protocol side. And this is new. We're going to talk about top chain. And Gift is going to go over it. So it will be very interesting. And then after explaining what and why, going over the updates. So there is a lot of content already there. And then the asking me anything at the end of the session. So please drop your questions so we can check them at the end. Yes. Right. So first, we are on Only Dust. So if you are interested in making contributions on open source contributions, you can find us on Only Dust. I will leave a link in a moment, and you can just see the open issues we have. If you have any questions, Oak is there to help, and everybody from the team, but Oak is the main one, responsible, like very responsive with all of the questions. And yeah, so this is a great way for you to contribute. We still have very few contributors, so you can be one of the earliest in the project and learn about CRDTs and learn about CROs and learn about all of the technologies we are using and developing. And of course, distributed systems, local first, and all of that. Yes. So it's a very cool thing. And then introduction to topology was the first call we did. It was last week. And it's very good for you to understand the context of topology protocol, how it came from experiments to the protocol, and then where we are right now and where we are going to. So if you haven't watched the recording yet, you should. So also in a moment, I'll drop the YouTube video, the YouTube link, so you can just watch it. It's very good, very accessible language as well. So it's very, it's easy to understand. And if you still have any questions, you can always drop them in the Telegram chat. But we highly encourage that if you are here, if you're interested about topology, you watch this session. Was hosted with and prepared with a lot of care by Guti. Nice. And then Topology Friends is the Telegram. So we are meeting now on Discord, and you can always leave questions on Discord, but our day-to-day conversations and GIF posting, there's a lot of love for K-pop and K-pop GIFs. So you can always drop them there and share all of the questions. So there's a very fast response rate and there's a lot of engagement. We also share all of the announcements in that channel. So it's a very casual and exciting. Yes, Oak is the best person to share the gifts. So you can compete with him for who's the best if you are interested in that as well. And yeah, so I'll drop the link in a moment in the chat. If you are not already there, you should join. And yes, that's it. So yeah, I'll pass the mic.
Patty, you're going to be disappointed because I have not set the title of part 2. So just saying, we're releasing a new blog post, and it will be part 2 of the origins of topology protocol from ledgers to sandcastles, and with a picture. This is the reveal, but the full blog post is going to be released soon. I'm still writing it. It's going to be a fun one, and it is going to dive into CROs. So if you have read the part 1 of the blog post, it hasn't covered CRO yet, but it covers our entire journey leading up to discovering the magical properties of CRDTs and our decision to do something about it. And part 2 is what we are doing about it, which is to create a protocol around CRDTs and have a new kind of decentralized network that runs this kind of new objects that we're calling CROs. So expect this new blog post to come out soon.
Oh yes, and the best way for you to see the new the part 2 actually is the newsletter. So I will also drop a link for you to subscribe and receive it as soon as it's out in your mail inbox. Yeah.
Great. So that's let's talk about our development updates on the topology protocol side. So on the left, you have what has been done. On the right, you have what we are currently working on. What has been done, the first item is release v0.2.0. So we released it roughly 2 weeks ago. The major change in this release is that we are dropping the notion of built-in CRDTs completely. And the reason for that is CRDTs have their custom-made consistency mechanism that is different from CRO. CRO has the hash graph, and hash graph is what is the thing that is keeping everyone consistent. And so for simplicity and coherency, we decided to drop built-in CRDTs. So from now on, it's just CROs. And if you want to compose CROs, we have a concept for that is blueprints. So you have blueprints that implement the basic useful CROs. Doesn't have to be basic, but expect to have a set of basic blueprints coming out of the box for you to mix and match into CROs that implement your application logic. Okay, so that's the new release, the latest release. A couple more things that have been done include a refactor job so that we are using a protobuf definition of the vertex everywhere instead of having redundant definitions of essentially the same abstraction, the concept of vertex in a graph. And we are also bumping the libp2p version. There is some complexity there, but we have been bumping the version, and I think the latest version is still progressing, and we're catching up to it. That's my understanding. Oak, you're on top of this. You can correct me and just call me out if I'm bullshitting in the chat. Working on the first item is finality. Finality is a really big thing. It's big in the sense that the entire blockchain thing is all about finality and reaching finality in a Byzantine in an environment where Byzantine behavior prosper. Finality in the topology protocol land means that CROs are these fast-moving objects where everyone is operating on it at super fast speed. That is our expectation. And their copies of the CROs may diverge temporarily. So finality basically means we want to have a notion of finalized information for each CRO so that these finalized information can be used to do something useful, such as compaction for the CRO itself. And also these finalized information can be sent to anywhere, including blockchains, to do something else, such as to settle trades or to trigger transactions in some smart contracts. So finality is sort of the key for CROs to communicate with systems like blockchains. Okay, and we're at the drawing board phase, meaning that we have multiple ideas and approaches how we might want to do this. This is a really tricky thing, and different approaches have different trade-offs, and we're currently evaluating them, trying to find the best one. It probably involves writing POC level code and running simulations to understand better their behavior. Okay, after finality, we have RPC. So this actually relates to the top chain concept that we're going to cover later. But RPC basically allows a topology node to accept requests and to do something on behalf of the requester. And before RPC, we didn't have this interface, but in order for TopChain to work, we need this interface, hence creating it right now. Okay, DHT. So DHT stands for Distributed Hash Table. Imagine a map, a key value map, only that it is distributed across many machines on a network. And the distribution is not fully replication, meaning that you have a bunch of key value pairs, and these are distributed, but not everyone keeps the entire dictionary, the entire map. So the thing about DHT is it allows you to efficiently find who has which key and go to that guy and ask for the value of that key. And why do we need DHT? Because we're currently using a very non-scalable way to do what is called topic discovery. Let's explain what topic discovery is. So each CRO corresponds to a topic on the PubSub network right now. And topic, each CRO also has a bunch of peers connecting to it, right? So the idea is for each topic globally, from a global perspective, each topic has a bunch of peers, but this global information is not sustained or provided anywhere. This is an kind of information that is distributed. So topic discovery basically is if I want to join a topic, I know the topic ID. Like I know which CRO I want to join. Can someone tell me one or a few peers that are already in that CRO so I can talk to them and get the latest state of the CRO and so on? Just give me a few that I can connect to. You don't have to give me every one of them because no one has that information anyways. So that's topic discovery. Specifically, we want to have a map from topic ID to a set of nodes that are currently subscribing to that topic. Then this is for people to bootstrap into the CRO, the topic. And so we're also currently working on that. The last two items are examples and documentation. Documentation is trying to catch up because we're making a lot of updates very quickly, and things are still in a quite fluid state. So it's quite tricky to write documentation, but we're working on it because if we would love hackers to hack on CROs, and a good documentation is a thing that unlocks that. Another thing is examples. So if you look into TS topology, in the examples folder, there are currently 3 examples: a chat example, a canvas example, and a grid example. We're also looking to expand examples, not directly in the TS topology repo, but in other repos, such as we're currently working on something called the hash graph visualizer. It is a CRO app that allows you to see the hash graph visually and see how the vertices are connected to each other and how new vertices are added to the graph in real time. Great, so that's the updates on the protocol side. Feel free to ask any question. I can't see the chat, but we'll address all the questions at the end. Okay, so now it's the time for TopChain, and this is a new topic. We have never publicly talked about this effort, although this code is entirely open source and we already have contributors working on it. But a TopChain is a blockchain, and in this call, we're going to tell you what is it and why we're doing it. So it's quite easy if we just look at this analogy. Everyone in Web3 likely knows about IPFS and Filecoin. IPFS and Filecoins, they are related. And how are they related? Well, IPFS, in a very simplified language, it's a system, a scheme to identify pieces of information uniquely, and to be able to find such information in a P2P network. So if that's IPFS, it's just a protocol that anyone can use without condition. And then you have Filecoin, and Filecoin builds on IPFS, and the value add of Filecoin is store files. And not only that, it store files in a decentralized network without a single organization or company behind. And how it works is a blockchain, and it has its own incentivization schemes for machines to contribute their storage and network resource to the Filecoin network so that the network has more capacity in terms of storing files. Okay, so Filecoin is a service provider that provides the storage service to the IPFS users. So if we like that idea, now we come to topology protocol. So topology protocol allows you to create something called CRO, and these are distributed objects. They are super fast to transact with. They're good for making real-time multiplayer programs where that is unstoppable because it's not bottlenecked by any particular server. It's P2P. And topology protocol is free to use without any condition. And then there's Topchain, and Topchain is a decentralized network that provides a specific service or value to the users of topology protocol, and that is subscription. So whereas Filecoin store the files, Topchain, the blockchain, subscribe to CROs. Of course, it's on demand. So if you pay Topchain for deals, so how it works is we're going to talk about next. But on a high level, you basically request which CRO you want to be subscription for, and you tell blockchain your request. And if nodes are taking up on your deal, great. Now they are supposed to subscribe to your CRO. And the benefit of that is CROs are by default ephemeral. But if you have Topchain nodes subscribing to your CRO, then it's not ephemeral anymore. As long as the token incentivization work and the validation work, your CRO is safe in the sense that there are always copies of your CRO being kept and as up to date as possible on Topchain. And any new guys can come in and bootstrap the CRO from there. So it's kind of remembered and recorded in real time on a Topchain. That's the value proposition of Topchain. A couple illustrations that may make it easier to understand. So what you have here is a super small decentralized RAM that consists of 4 nodes. So you have 4 topology nodes, and they're connected in a peer-to-peer fashion. Okay, so this is where Topchain comes into picture. With Topchain, you have the 3 green guys, bottom left. These are the Topchain nodes. And if you look into the Topchain node, it basically has another topology node for itself. It also runs a validator node. And we're currently using Cosmos SDK to build this blockchain. So this is basically the Cosmos validator node. Okay, and you can see these validator nodes, the orange circles, they are connected by orange lines. This means that the validators nodes run on a separate P2P network that is separate from DRAM, the decentralized RAM P2P network, or the topology node P2P network, which is the black lines. And now we have a deal. A deal basically is a request to subscribe to a CRO for a duration and to earn a specific amount of money. That's the deal. That's the reward that comes with the deal, and the reward that the requester is putting up for the Topchain nodes to earn from. Okay, so you have a deal here about the blue CRO, and you can see that this deal now is active in the sense that 2 topology nodes are subscribing to the blue CRO, and they have the blue circles in their topology node. You also have Alice and Bob. These are the regular users that are also just using the blue CRO, and they can be running their topology nodes on their smartphone or on their laptop. Ideally, any device should be able to run topology node with as minimum resource as we want. This is not a blockchain node, so we really care about the pervasiveness and convenience of running a topology node, even on resource-constrained devices. So you have Alice and Bob being the users of the blue CRO, and you have 2 Topchain nodes being the service provider of the same CRO, and they're subscribing to it. They're keeping the updates, and new guys can come in and query the updates and can bootstrap up to it and so on. So this is Topchain for you. Now we can talk about the development updates on top chain. So what has been done is a lot of the basic and essential stuff. So we have the essential modules all set up using Cosmos SDK, and so account bank, staking, and so on. We also have the most important module, that is the subscription, and this is where the Cosmos chain that we're creating is connected to the topology protocol. It's by way of this subscription module. This subscription module describes how deals should be handled. So a deal, again, is a request, so that I can request, I want my CRO to be subscribed from this block to this block, and I'm willing to put up this amount of money for people to subscribe to my CRO. So that is a deal. Now we have implemented the basic verbs around a deal. So you can create a deal, you can cancel it, update it, as in you can prolong the deal, because you want your CROs to be subscribed for a longer period of time. You can also increase the reward amount. There are scenarios where you realize that the reward you put up is below market rate, in the sense that you have less providers willing to take your deal and subscribe to it. So you may want to increase the reward to have more providers come in and accept the deal and do the job for you. On the provider side, so provider is the top chain nodes that are providing the service to a deal, that they are the providers. They can join a deal and they can leave a deal. And they only make money when they're actually in the deal and doing the work. That's when they make money, and basically taking a share of the reward from the deal. You can also query a deal, basic stuff such as status, is the deal active or not? You can query a deals, who are the active providers that are currently working on the deal? You can query the deal's block reward, in the sense that for the amount of money left in the deal, how much money can be earned in the next block, for example. And providers may use that information to see, does it make sense for me to join the deal and make the money there, or is it not worth it? Okay, so all these are done. We're working on the right side, unit testing. That's self-explanatory. RPC, we obviously top chain nodes need to be able to accept and process RPC requests. So that is being worked on. And chain design. So this is still in the research phase. By chain design, we mean that we need a way to verify if a provider is actually a provider who accepts the deal is actually doing the job the deal requires. And we need to do this verification in a way that is trust minimized. So basically, it's a verification scheme to check if people who people who said they are doing the job is actually doing the job. And we're currently in drawing board phase. We have a good first solution conceptually, which uses a fraud-proof scheme. So it's an optimistic scheme, and during the challenge period, anyone is able to challenge a provider and say, hey, during block 170, you said you were subscribed to a CRO and you did the work. I challenge you that you're actually lying, and you then enter into a interactive process. Details are not being worked out at all yet, but you enter into a process that sort of nails, we are going to check a piece of information in your claim, in the provider's claim. And if the check passes, then the challenge fails. If the check fails, then the challenger wins, and money gets to be made by the challenger. So it's a scheme that we're creating to keep the providers honest. If they accept the deal and are making money from the deal, they should do the job. Okay. So that was our last update slide. Join us in our Telegram group. As Patty said, it is a fun group to where we talk about topology protocol or whatnot, and all our code is open sourced on GitHub, Topology Foundation repo. We're also on OniDust, and this is where you can find us on OniDust. We have a lot of issues that are open to contributions. There are very few easy issues. They're all interesting issues, but very few easy issues in the sense that we are still an early project and we're doing something quite special and unique. So these issues, without a lot of context, can be difficult to work on. But these are interesting issues, and we welcome early contributors. That's it for the updates. We're going into the Q&A session.
Awesome. Thank you for the presentation and the updates. Oak left some comments in the chat when you were talking about the updates, the protocol updates. Yes, you left. You don't, but we don't need. You said we don't need to go over them. No questions so far, and just a small corrections, I think.
Mm-hmm.
Yes. So no questions yet. Do you have? If you have any, we have some new people in the call that joined us afterwards. We have Mitch, Havitz, Jamel. If you have any, and Maurice, I think you are the only ones that joined after we started. If you have any questions, leave them in the chat. Oh yeah, Oak said that everything was super clear. That's why we have no questions. But if you are just joining us and you want to know more, we can explore. So just let us know. Jamel is typing something. So yes. So yeah, Jamel said that we are trying to understand before. And then we have some more people typing, maybe questions, maybe comments.
Yeah. Any question is welcome. Even questions that you think are super basic or you think are assumptions that everyone else already know is totally fine. We're here to talk about anything about topology protocol, and TopChain now also in the picture.
Okay. First question from Gilman. Is there any document that explains the issues arising when merge conflict happens? I did not understand the section 10 snapshot in the paper.
I see. That was two questions. One is about merge conflicts, and the second is about chapter 10. Could you remind me of the? It's a section about snapshots, right?
Yes. Mm-hmm.
Okay. Yes. So merge conflicts. So we have hash graphs. That is the append-only log of this distributed object, and hash graph is always mergeable in the sense that if you have honest vertices added to the graph and they're connected to the graph, they depend on things that are already in the graph. If you do it this way, then you modify your graph, I modify my graph. Our graphs are always mergeable. There will be no conflicts that happen during the merge. But there's still the notion of conflict, and that is at the CRO level, not at the hash graph level. Hash graph is always mergeable, and bad stuff is not going to be merged. It will stay outside of the graphs of the honest guys. But at the CRO level, so we forget about hash graph. There's a notion of conflict, and that basically means things as simple as if I have a number, let's say you have a CRO that is a single number, and I am adding 1 to it, and you are multiplying the number by 2. And we're doing it at the same time. Then which one comes first? Should the number be should a number plus 1 then multiply by 2, or should a number 2x then plus 1? These give you totally different answers. So that is a conflict in the sense that you have operations that happen concurrently, and their order of execution really matters. You will get different results. In that case, in the CRO, and this is not, this is very clear if you go to our TS topology, check the examples, and just check the CRO code under the objects folder. You can see what I'm going to tell you next, which is you have to understand something called semantics. Semantics is just a very fancy word for meaning. And in this case, when we say meaning, we mean that when people are doing things concurrently to a CRO, what is the meaning of that? As in, how would the CRO react to that and behave under this concurrent things? You need to define it in the code of the CRO yourself. So, for example, I can say, okay, my number allows people to add perform addition to it and also perform multiplication to it. And I need to define the semantics. What if addition and multiplication happen at the same time? Well, you notice that if we have additions happen at the same time, it doesn't matter, right? Because the ordering doesn't matter for addition. You can add numbers at whatever order, the result is the same. Also, if you only have multiplication, it also doesn't matter. You can multiply numbers in different orders. They give you the same result. It's only when you have addition and plus and cross addition and multiplication in the concurrent batch, they happen concurrently, then it gets problematic. You need to program the CRO specifying what happens then. You can say, okay, if I have a whole bunch of additions and multiplications that are parallel to each other or concurrent to each other, I will do all the additions first and then do all the multiplications, right? That will give you an answer. And if every honest guys on the network follow the same recipe here, then they will get the same result. Do the additions first, then the multiplications. You can also do it reverse, right? Just do all the multiplications, then do the additions. You can also just say additions win. So when you have additions and multiplications happen at the same time, you just drop the multiplication and do the addition. And whichever way you want, but the only thing is this sort of recipe or this semantics needs to be defined in a way that is deterministic. In a sense that, so for example, you can't say, I'm going to run a local random number generator and pick a random number and use that to sort this situation out. That is problematic because honest guys can be generating different random numbers locally, and they will resolve the situation differently and they get different answers. And that is not what you want. What we want ultimately is all the honest guys follows the code of the CRO, the recipes, and they're guaranteed 100% to see the same thing eventually. That is the ultimate goal. So it is on the CRO developer side to specify in the CRO code how does your CRO behave under concurrent operations. So that is to your first question. Feel free to ask follow-up question in the chat. I'll go to the second question. Okay. Snapshot. So snapshot requires finality to perform, in a sense that snapshot literally is taking a picture of the CRO. But CRO doesn't exist in a single place, in the sense that CRO is a virtual concept. The physical copies of CROs, they live in a whole bunch of users' machines locally. All these copies together is a CRO. And so when you say, I want to take a snapshot of a CRO, really, you ideally want to do is you want to ask every users of the CRO, hey, tell me your copy, and I will aggregate all the copies and summarize. That is the snapshot. But that is not realistic in the sense that you may have a million, well, that is ambitious, but you may have a million users using the same CRO at the same time. So to take a snapshot, do you really want to ask a million machines to send you their copy over the internet and that is your snapshot? Maybe you don't want to do that. And maybe these guys are going offline and online. You don't even know at any given moment the list of people that are in the CRO, a global list. So you want to do it in a way that is robust to people that are under different network conditions and under what we call dynamic membership, in the sense that people can join and leave your CRO. Notice that this is trickier than what the typical blockchain design is subject to, in the sense that if you have a blockchain, under proof of stake, for example, you have people that are putting money at stake. And when people put money at stake, their names are on the validator list. Everyone knows who they are and how much money they have on stake. It's on chain. So that is your membership. You can always derive a snapshot just by asking the validators, and they're all named. But in a CRO, you can have fresh node IDs created fresh, and they come into the CRO and they have a copy. Right? So in that case, you don't have global information who these guys are, because they just joined and there are new identities. So CRO is a tricky situation because it has dynamic membership and people are connected from their local machines, smartphones, laptops, and under different conditions. So we need a way to do finality. So the thing is, if we finalize information about a CRO, such finalized information can derive a snapshot, right? So in a sense that if we know what vertices are finalized, then the collection of all these finalized vertices, ideally they form a graph. That graph is a snapshot of the CRO, or of the history of the CRO, if you want to be precise. So that's why we're doing finality. That's why on this page, the first item here is finality. This is really important. One reason being finality allows us to do CRO snapshotting. And another reason is finality allows us to do compaction, in a sense that if the CRO agrees these vertices in the graph are finalized, then we can think about garbage collecting them. Like we don't require everyone to remember the vertices forever. If some of them are finalized, they can be stored elsewhere, such as on archival nodes. If we take the blockchain example, they can be just dropped, because if finality is giving you the finality guarantee, final, then everyone has the information, so you can fast forward the CRO state, basically for the state by applying every operations in these finalized vertices. So you get a new state. Let's fast forward from the previous state, and you can drop all these vertices. And from now on, our starting point is the new state here. That is called compaction. That's why finality is important.
Okay, so thank you, and Gilman is saying thank you. He has a follow-up comment. He said that these rules for solving issues caused by concurrent operations should be made by you. Who is you in this P2P network? And maybe you already answered that. Okay, yeah, it has already been answered. All right. So it seems it's okay. So we have a question on CROs by L. And consider I have a CRO on some nodes and I am willing any amount for my object to last for a long time. How you ensure security of my CRO? Will there be possibility to set authorization on my CRO?
Yes. Authorization schemes. It is something that we're actively exploring, but it's not on the list of to-dos. It's more in our conversations. It is actually a tricky thing, and So feel free to elaborate on your question. My understanding of the question is, what have we thought about authorizations of CROs? Who can do what to a CRO, basically, at a given moment? We haven't tackled it in the code base. That's what I believe. And this is actually a very complex topic. And this topic also has relationship with finality. Who can do what? So imagine a crazy example where you have a CRO that is totally permissionless, in a sense that any machines on Earth can subscribe to the CRO and can generate operations to it. In this situation, finality is super tricky because it's permissionless. We are also considering such a use case or such a scenario. And when it comes to authorization scheme, the obvious pattern is to do access control list, right? So the super naive situation is you spawn a CRO, and in the constructor of the CRO, the constructor specifies the list of guys that is the admin of this CRO. So it's whitelisted at the time the CRO spawns. Then this CRO has a fixed membership. It's just these guys that are allowed to generate operations against it, that can write to it, basically. So that is your super basic example. Now you can have more advanced examples, such as, okay, you have admins, but admins can also give permissions to other new nodes. And admins may also revoke permissions from those nodes. And you can also specify if admins can revoke the permissions from each other. That is a weird situation in that you may have two admins that are trying to revoke each other's permission. Then it's a weird situation. Who is winning at the end? We have not given this a systematic consideration yet, but this is a truly important subject. Yes.
Cool. Yeah. So thank you for the answer. Let's see if there. Okay, we have one more question. Quote: instead of unanimity, the tick advances by threshold. The tick advances by threshold amounts of subscriber nodes signing and acknowledging messages. 3 consecutive ticks can be used to form a consensus round, yielding a snapshot. Finish quote. Mm-hmm. Question: is there any reason for exactly 3 consecutive ticks? And based on what are you choosing the threshold amount?
Yeah, this is from the white paper, and it is using something called TLC, or it's a distributed logical clock. The idea is that the idea of TLC, and I encourage you to go to the original paper and understand TLC from how the author introduces it. It's quite an interesting paper to read. It almost works like a tutorial. But the TLDR of TLC is, and to answer your question, the answer actually lies in the paper. But so TLC is a clock, but a distributed clock where a lot of machines are trying to maintain the clock, but they want to be able to run this clock fast. And if you want to run a distributed clock fast, you cannot have all the machines synchronizing all the time, because synchronizing takes a lot of time going on the network, and your clock gets slow. It gets bounded by network delay and network conditions, people that are responding fast and slow. So you want to reduce synchronization or reduce synchrony in your system. The way TLC does this is that everyone in this TLC system, they operate their own ticks. Tick is just an integer that goes up incrementally. So tick 1 followed by tick 2 followed by tick 3 and so on. And from everyone's own perspective, the tick is incremented when certain conditions are met. And the conditions look like I would announce some information to the network, and I'll be collecting acknowledgements. People that are basically calling back and say, hey, I saw your message. And they will call back giving me a signature so that I know that that acknowledgement is valid. And I'm collecting these signatures, and I count if I am collecting enough signatures, then I'm packaging all these signatures into a single signature, and I'm broadcasting this again to the network. And I'm collecting people acknowledging they have seen this packaged signature. And then I'm counting these acknowledgements again. When this passes a certain threshold, we'll elaborate on threshold later. Then my tick advances from, like, let's say, tick to tick +1. And I keep doing this procedure, running a clock. And the property of the TLC is that the clock is running as fast as it can. And although the machines may have different tick numbers locally, but their numbers are, I think, empirically to be very close to each other because they're catching up to each other all the time. So instead of everyone running the same number and the time basically moves as a single integer, you have in TLC, you have everyone running their own tick. And so it's different numbers, right? Imagine different progress bar going at the same time. And because of the design of TLC, these progress bars are different, but they're pretty close to each other and they're catching up to each other. So they're advancing as fast as they can, but in a very distributed, decoupled manner. So that's TLC. Again, these questions can be answered by reading the paper, but to answer your second question, why do we do consensus round over multiple ticks? Because a tick gives you certain guarantees on who has seen what information and who has seen such information. You have this sort of knowledge chain. I know that you know that I know something, right? And this knowledge chain gives you certain guarantees. So you can use consecutive ticks to give you a certain guarantee when it comes to consensus. You can say, okay, in the first tick, I will let everyone propose something. Let's say just in a voting procedure, everyone propose something, and that something goes through the TLC process as I explained. So go to the network, collect signatures, and go back out again as a package signatures and collect the acknowledgement again. But then you can use this result from the first tick to do your second tick, which is different from the first tick. In the second tick, you're just trying to announce the packaged signature again from the previous tick and do further collection of the acknowledgements. And that basically sort of seal the information even more by requiring more people to see that and to perform signatures over it, right? So you can see that if you use more ticks to create your consensus round, then your consensus becomes firmer, becomes more solidified. So that actually is the idea of TLC, is that it tries to give you this gadget that is the clock that advances in a distributed manner, and you can make consensus mechanism on top of a TLC, but it depends on how much guarantee you want. You can use a TLC the way you want, including setting the threshold. So threshold is just a number between 0 and 1. So for example, if I know that my network has 1,000 members and I want a threshold of 0.6, then every time I collect signatures, I'm waiting to collect 600 signatures before I advance. That is, the threshold is just a fraction between 0 and 1. If you want full consensus, then your threshold is 1, meaning that if there's 1,000 nodes, then whenever I broadcast something to the network, I'm always waiting for 999, like all of the rest of the guys to acknowledge my information before I advance. It's just a tunable knob in this primitive. Make sense? You can ask follow-up questions. But I think just a heads up, for finality, we're exploring a lot of options, and TLCs or TLC inspired option is one of the many options that we're evaluating.
I think he said thank you, so no follow-up questions on this. That's nice. And we are almost on top of the hour, so if you have any final question, you can share it. I think we have time for it. If there are no questions, I think this is it then.
Nice.
Okay. Awesome. Thank you for coming, everyone. we had new people coming, asking questions about the white paper. So it's very good to know you have been doing some studies, and hope you are already on Telegram. I dropped the link here to connect on Telegram and contributions for Omnidesk and all of that.
Yeah, hope to see you in our Telegram chat so we can chat more. Yep, otherwise, check out our new blog post when it's out. And we have a lot more materials planned. New blog post, the next intro to topology call, for example, in a few weeks' time. And of course, DEF CON, where we hope to see you in person.
Yes, for sure. And you will know how to find us in person if you are in Telegram. So it's really a must if you're going to DEF CON, and stay connected. And thank you everybody for coming. Great to have you. Oh, okay, I have to take you to the tele. It's good. Go for a walk. The best excuse is to have a dog, so you have to leave the house every now and then. All right.
Thanks, everyone. This is it. Thank you. Have a good night, good morning, good evening. Bye.
Bye.